In this video, we're gonna determine the dimension of a square footing. Well, we have the data. We have the axial load, the depth of foundation level, the unit weight of soil, the undrained cohesion of the soil. This is a cohesive soil. The friction angle is equal to 0, and we have to find B. Remember, this is a square footing. Okay, we are going to find B using the Skempton's theory with this equation. Bearing capacity is equal to cohesion by bearing capacity factor plus unit weight of soil by depth of foundation level. In order to find the bearing capacity factor NC, we will use this graph. In the x-axis, we have D between B. In the y-axis, we have the bearing capacity factor NC. As you can see, we have two curves, for a square or circular footing and another one for a strip footing. Our footing is a square footing. Now we will use this curve. This curve is represented by this table. For D between B values, we have NC values if the footing is a square or circular or a strip. This table is very useful, but what if I have D between B value equal to 1.20? It's not here. So you would have to interpolate a value for that. In order to avoid that, we have graphed the curves. The blue curve is for a square or circular footing, and the orange curve is for a strip footing. This graph is the same of this graph, but we have limited to D between B less than 2.50. These equations represent the curve with a correlation coefficient pretty close to 1 to indicate a very good correlation. With these equations, we can get any value of NC capacity bearing factor. Well, we propose an initial breadth of foundation B. The depth level of foundation is equal to 820 feet. 820 feet. The unit weight is equal to 9571. 9571. The cohesive of the soil is equal to 501.67. 501.67. In the axial load, is equal to 160 thousand pounds. Well, in this problem we have a square footing. To footing square, the equation is for the blue curve y and z. In the x-axis is d between b, x d between b. X d between b, x d between b. What about 1? D between b is equal to d between b, but b is equal to 1. Okay. And the in C factor is equal to, we use the equation of the blue curve, d between b to a square plus by d between b plus 6.2451. Enter. The bearing capacity admissible is equal to the cohesion by NC factor between a security factor. The security factor usually is between 1.5 and 3. In this case, we will use security factor equal to 3 plus the unit weight of soil by the depth of foundation level. Very good. But this capacity bearing of soil is equal to a load between area. In this equation, the area is the area of the footing, but it's a square footing. Is b by b. Clearing the value of b is equal to the square root of the load axial between the capacity bearing b is equal to the load axial between the bearing capacity square root. Well, is not equal to the initial b 15.19, and we will copy these values, but first we will let's fit some values. In this, we will fit the depth of foundation level because it's gonna be constant. In this one, it's okay, and in this one, we wanna fit all values except NC. Fit. Let's fit. Okay, and fit this value because the load actual is constant in calculation. Well, copy and paste, copy and paste, copy and paste, and copy and paste. Well, now we get a b equal to 9 feet. Is different to the initial b. Let's continue. Now the initial b, it will be equal to 9.02. 9.02. And copy, copy, paste, copy, paste, copy, paste, copy, paste. Now this b and this b are very close. Now with this value of b. Now copy paste, copy paste, copy paste, and copy paste. Now this value of b is exactly the initial b we will propose, and then the process is ended. We have found the value of b that according to Skempton's theory is equal to 8.84 feet. Thank you for watching the video and subscribe.